Hello dear students, today's new chapter is probability and first lesson is calculating probabilities. As we know, probability is all about the likelihood of a certain event to occur. For example, rolling a die or tossing a coin. Usually the probabilities have values between 0 and 1. 0 means the chances that a certain event will never occur, and 1 means the event will certainly occur, so 100%. Otherwise, we can say like 0% and 100% because we are more familiar with this one. Mathematically, we say it's a number between 0 and 1. If the probability of a certain event is close to 0, then we say it's very unlikely to happen. So that event is very unlikely to happen. If the probability is close to 1, like 0.999, for example, or 99.9%, then we say this is very likely to happen. Usually we use, like when we're certain, we use 99.9%. There is this formula that we use to find a certain probability for an outcome. Now, probability of a successful outcome will be the number of successful outcomes over the total number of outcomes. Let's solve some exercises from this part. Let's start with exercise 1. A letter is chosen at random from the word probability. What is the probability that the letter is? The first question is a letter B. So let us count how many B's is. Let me write here. Probability of B is, how many B's do we have? We have one B here and one B here. So we have two B's. That means there are two outcomes that are successful. So two B's. And how many letters are in total that we can choose? Well, if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 letters, so 2 over 11. We can leave it as a fraction or convert it into decimal number, which is 0.18 repeated. The second question is what is the probability that the letter is a vowel? So let us write here probability of the letter being a vowel. Let me remind once more. Vowels are these letters, are A, E, I, O, and U. So these letters. Now let us count how many of the previous letters are A, E, I, O, or U. So we have one O, one A, we have one O, one A, one I, another I. So we have four vowels over 11. The total number of letters in the word probability is 11. That means 4 over 11, it's 0.336 repeated. All right, let's go to the next exercise. A box of chocolates contain 8 hard-centered chocolates and 6 soft-centered chocolates. Hazel takes a chocolate from the box without looking. So she's not looking at all there. What is the probability that the chocolate has a hard center? All right, again, the same as the previous exercise. Probability of hard-centered is what is the number of all successful outcomes? In this case, our successful outcomes means to get a hard-centered chocolate. Well, there are 8 hard-centered chocolate. And how many chocolates are in total? Well, in total are 8 plus 6. 8 hard-centered plus 6 soft-centered chocolates. That means 8 over 14, which we can leave as it is or cancel to 4 over 7. And we can leave it as this, or we can convert it into decimals. And in decimals, this is 0.571428, if I'm not mistaken. Under B, the second part of the question is a soft-centered. Well, it will be totally the same, just now we change this one to soft-centered chocolates. The probability of being soft-centered chocolates, it will be 6 over 8 plus 6 again, and that is 6 over 14, which actually is 3 over 7. And 3 over 7 is 0.424285171. Repeated. All right, that was it. Exercise 3. Probability of an outcome that does not happen. Well, we have two chances, like if we represent them as sets. There are two chances. Either an event happens, either it doesn't happen. So there is no third option. Either the event happens, either it doesn't. What does it mean? That means the probability that an event occurs, like happens, plus the probability that it does not happen, must be 1, which means 100%. So we are sure that it must either happen, either it doesn't happen. So how does this one help us? Well, if we know that the probability that an event occurs, then the probability that it does not occur is 1 minus it occurs, or the opposite. If we know the probability that it does not occur, then the probability that it occurs is 1 minus does not occur. All right, let us apply this formula. So baby Miguel has 3 teddy bears, 2 books, 1 ball, and 10 boxes in his toy box. His mom takes a toy out of the toy box. She gives the toy to the Miguel. What is the probability that the toy is? Under A, first question, a teddy bear. So probability of being teddy bear. It's the number of successful outcomes. Well, how many teddy bears we have? We have 3. What is the total number of toys? Well, 3 plus 1 plus 2 plus 10 is 16. So it's 3 over 16. Let us leave it like this. Probability under B, probability of being a book. A book. How many books we have? 2. Over how many objects we have? 16. So 2 out of 16. Actually, we can cancel this by 2, so we get 1 over 8. Under C, not a book. All right, now we can use the previous formula. Probability of not being a book, is, well, we can do it both ways. We can just count how many elements are not books. In this case, there are 3, 1, and 10, which is 14 not books over 16. After simplifying, we get 7 over 8. Or using the formula, not a book, is 1 minus probability of being a book. Well, this is 1 minus 1 over 8. And 1 minus 1 over 8, we can find the least common multiple, which is 8. So 8 over 8 minus 1 over 8, it's 7 over 8. Next part is question D, either a block or a ball. So it can be a block or the ball. So we have 10 blocks and 1 ball, that means 11. Let us write here probability block or ball. Block or ball is 1 ball plus 10 blocks over 16, which means 11 over 16. Let's go to the next exercise. From exercise 15.1, this is exercise 1. The spinner is spun, this one, which has two black parts, one red, one blue, one yellow part. All of them have equal area. What is the probability the spinner will land on red? All right, the probability that it's red will be 1 out of 5. There is one red out of 5. Question B. What is the probability the spinner will not land on red? All right, probability of not red. The probability of not landing on red, we can actually count how many are not in red, or we can use the formula 1 minus probability of being red. And this one is way better. 1 minus 1 over 5 is 4 over 5. Exercise C. What is the probability the spinner will land on black? The probability black. The probability that the spinner will land on black. We have two black parts, this and this. So it will be 2 over, we have 5 parts in total, so 2 over 5. Question D. What is the probability the spinner will not land on black? Probability the spinner will not land on black, so not black, will be 1 minus 2 over 5. So this is 3 over 5. All right, let's go to the next exercise. The probability that someone leaves a message on Todd's answering machine is 0.25. What is the probability that the next caller does not leave a message? All right, let's write here. Probability leaves a message. Is 0.25. Well, the probability that leaves plus the probability that does not leaves a message, plus the probability it does not, the probability that does not leave a message must be 1. So what does that mean? The probability that the next caller does not leave a message will be probability will be 1 minus probability it leaves a message. Actually, this is 1 minus 0.25, which is 0.75 or 75%. Next one. An ordinary fair die is rolled. So this is an ordinary fair die. It has 6 sides, numbers from 1 to 6, and the probability that each one will occur is the same, 1 over 6. What is the probability of getting a number less than 3? All right, a number less than 3. Probability being less than 3. Well, the probability of being less than 3, there are two numbers that are less than 3. It's the number 1 and it's the number 2. So 2 over 6, there are total 6 number of outcomes, which means it's 1 over 3. Question B. What is the probability of getting a number not less than 6? Not less than 3. So not less than 3 are 3, 4, 5, and 6. Read it carefully once more. Less than 3 is 1 and 2. It's not 3. But not less than 3 means not being 1 and 2, so 3, 4, 5, and 6. Well, probability not less than 3, not less than 3. Actually, we can calculate it like that, 4 over 6, or we can write 1 minus probability of being less than 3, so 1 minus 1 over 3, which is 2 over 3. Done. Question C. What is the probability of getting a number greater than 3? Probability of greater than 3. The probability of being greater than 3, so which numbers are greater than 3? It's 4, 5, and 6. Here we stop because there are no bigger numbers on a regular die. So it's 3 over 6. After cancelling by 3, we get 1 over 2. Why are the answers B and C not the same? All right, you can try and give this answer. A bag contains only black and white counters. The probability that the counter is white is 1 over 6. A counter is taken from the bag at random. The counter is white. It is not replaced in the bag. So now, the first question is, what is the smallest number of black counters in the bag? So, if the probability is 1 over 6, if the probability that the counter is white is 1 over 6, that means for every white counter we have 5 black ones. So the minimum number of counters, black counters in the bag will be 5. Let us write here for every one white we have 5 black ones. All right, so minimum we should have 5 black ones. So we got the only white one which was there. Let's see the second part of the exercise. A second counter is taken from the back. This counter is placed next to the first counter. It is also white. What is the smallest number of black counters that can now be in the back? All right, if we got another white one, that means we had at least two white ones. If we got 2 white ones, that means there were at least 10 black ones. So because for every one white we have 5 black, that means if we chose by random 2 white ones, that means we had 10 black. So at least we have 10 black counters. All right, thank you. See you next lesson.